Hello everyone, this is Yali Wang. This video is for solution 2 of homework 8 of EL6303. For this question, we know the Poisson process with a parameter lambda, and we defined a new stochastic process x of t. It equals 1 if n is odd, and it equals -1 if n is even. So for the first question, we need to find the probability of x of t equals 1. So because we know from the question that the probability of x of t equals 1, that means n is odd in the interval of x of 0 to t, like t equals t2 minus t1. So we can get and also we know that the probability of n equals k, it equals e to power minus lambda t times lambda t to power k over k to factorial. So we can get the probability of n is odd, it equals the sum of k from 0 to n, e to power minus lambda t times lambda t to power 2k plus 1 over 2k plus 1 factorial. It equals we can get make the e to power minus lambda t out. So we can get it equals the e to power minus lambda t times the sum of lambda t to power 2k plus 1 over 2k plus 1 factorial. Because we know that this function, so we can set the first equation equals is 1 and the second equation equals 2. So we can easily get that we make 1 minus 2, we can get 2 times x plus x to power 3 over 3 factorial, and so on. It equals e to power x minus e to power minus x. So we can easily get the sum of xt to power 2k plus 1 over 2k plus 1 factorial, and equals e to power lambda t minus e to power minus lambda t over 2. So we can easily get the probability of n is odd. It equals 1 minus e to power minus 2. It equals 1 minus e to power minus 2 lambda t over 2. Similarly, we can use the same way to get the probability of n is even. It equals 1 plus e to power minus 2 lambda t over 2. For the second question, we need to find the expected value of x of t. So we can find that the expected value of x of t, it equals e to minus e to power minus lambda t times minus 1 plus x minus x to power square over 2 factorial plus x to power 3 over 3 factorial minus and so on. So we can through calculation we can easily get that it equals minus e to power minus 2 lambda t. For the question C, we need to find the R function. We know that the R function t1, t2 is equals the expected value of the product of x of t1 times the x of t2. So if t equals t2 minus t1 is greater than 0 and the x of t1 equals 1, so we can easily get the x of t2 equals 1 if the sum of the points in t1 to t2 is odd. So we can get the probability of x of t2 equals 1 given x of t1 equals 1, it equals 1 minus e to power minus 2 lambda t over 2. Multiplying by probability of x of t1 equals 1, we can get the probability of x of t2 equals 1, x of t1 equals 1, it equals 1 minus e to power minus 2 lambda t over 2 times 1 minus e to power minus 2 lambda t1 over 2. Similarly, using the same way, we can get the probability of x t2 equals 1, x t1 equals minus 1, and it equals 1 minus e to power minus 2 lambda t over 2 times 1 plus e to power minus 2 lambda t over 2. So similarly, we can get this equation and this equation. Because we know the product of xt1 and x of t2 equals 1 or minus 1. So we can easily get Also, we can just reduce the details. We can get conclude that the R function of T1 and T2 is equals e2 power minus 2 lambda, the absolute value of T2 minus T1. So for question D, we need to find if x of x is WSS. Because we know the expected value of x of t equals minus e2 power minus 2 lambda t, which is not a constant, so we can easily get x of t is not WSS. That's it. Thank you.